Well, after Europa, one of Jupiter's moons, we're now looking at one of the asteroids. In fact, the largest of the asteroids. It's 940 kilometers across. And we're going to approach it. Imagine us coming in from space, and we're approaching the asteroid, which is over there and indicated by all those canes, and we'll make some sense of those canes in a minute. But what I want to do is start with what we bump into first as we approach the asteroid. And the first thing we notice is that in a ring around the asteroid there are chunks of granite. So the bits of granite are indicated by the round discs, and we'll come to the granite in Ceres later, but these chunks of granite chemically are the same as the ones in the asteroid itself, so they're probably left over from the early stages of construction of the asteroid. Now, one thing which is perhaps new and which astronomers may not be aware of is that in addition to these lumps of rock and possibly dust as well in this ring around the asteroid, there is in fact a band of water vapor, and this is the width of the water vapor as indicated in the magnetic model, and the band is about that thick. So there's a significant amount of water vapor in a disk around the asteroid, and importantly it goes all the way round. The sun is on that side of the asteroid shining in, and if the astronomers were correct and the solar wind blew the molecules of water away, then those would be gone. But the disk of water is still there. So it may be the astronomers are going to have to do a little bit of rethinking on this, because as we'll see, this band of water vapor could be reasonably permanent. Right, as we move in now, we're going to come to the asteroid itself, and like mini planets, it's sort of classified as a mini planet. We're going to expect to find that it's got a core of iron and heavy materials and an outer layer of lighter sort of granite-like materials. And if we just move in, what I've done is I've indicated the sort of the equator of part of the asteroid here. So the magnetic field is as a sphere sort of going in like this. This is the outside and it goes in, and if you like, hula hoops a bit small, but there you've got the center of the asteroid, and then you've got the different layers. This will be one layer, sort of an onion ring sort of approach, and then it goes out with this being the outer edge of the asteroid. Looking at it a different way, we can say that up here we've got the North Pole, and down here we've got the South Pole of the asteroid. Now, we actually approach it by using a probe. So we have a probe here. Remember, this is the outer edge of the asteroid, and we just poke that probe in and then analyze what's there as we move in towards the center. And what we've done is we've actually put the different layers on the central pole here so that we can actually look at it vertically. In other words, from the north of the asteroid down to the south pole of the asteroid. Now, what is well known, of course, is that it looks a bit volcanic on the outside, with a few craters and things like that. And so the first layer that we've got, which is up here, comes up on lava, volcanic ash, and various things you associate with volcanic activity. But as we probe in, we do not find any water in that outer layer. It's not until we get within it and a bit deeper that we actually find water. So there's a layer of water indicated by that blue tape there, which presumably is over most of the asteroid. So there is a layer of water trapped in the volcanic debris. Then underneath that layer of ash and water, you come to the granite layer itself. So you then have a sort of 100 meters or kilometers or so of granite which comes down here, and then that granite layer is going to interface with the iron core. But interestingly, at that interface, now we know why the interface is there, the thing is sorting itself out gravitationally, so all the dense stuff goes to the center and the lighter stuff stays at the top. So at this particular point here, we find the intermediate elements such as copper and zinc and calcium. So they heavier than the granite, so they're stuck there. They're lighter than the iron, so they don't sink any further. So once we've passed that layer, we're then into the iron core. So from that yellow bit there, tape there, down to that yellow tape there, we've got the iron core. But within that core, you've still got gravitational settlement. So from the lighter elements, you're now going to move to the heavier elements. So you're going to find your nickel and all the other things which are heavier. And importantly, the really heavy stuff is going to be at the center of the asteroid. And of course, amongst these heavy stuff are your gold, iridium, the really heavy elements. So that's where, if you're going to go gold mining, you have to burrow about 400 kilometers to get to the center. Now, this is only a small object as far as the astronomers are concerned. It's only just over 900 kilometers in diameter, and one would not expect that it would actually take on the form of a planet with a central core and then an outer shell. But in point of fact, it's like Europa. If Europa, we found, had a lot of radioactivity at the center. And similarly, with this asteroid, at the center here is a whole load of radioactive material. And there was enough of it to melt the center of the asteroid and provide time for this sedimentation of the elements so that they form these different layers, and also for the granite to come to the surface and appear on the surface of the asteroid. Now, we know that because we can pick up the thorium, which is a radioactive material, and like Europa, we can identify that it is still active because the radioactive activity, if you like, is producing neutrons. And if there's some nitrogen around, then those neutrons will combine with the nitrogen and form short-lived carbon-14. And up in this zone here, we've got carbon-14. And that shows us that the atomic reactions which are providing heat are still going on to this day. What we don't know, of course, is whether the center is liquid or solid, but my bet is, being such a small object, they're going to be solid now. Liquid earlier on, but perhaps solid now. So there we have what you might call a mini planet. It's in the asteroid belt. It's something which astronomers can see through their telescopes, including amateur astronomers, and we can identify which side is pointing at the sun at any particular moment. So we know that at this particular moment the sun is on that side. But what we haven't been able to do is identify so far those bright spots that the probe that the Americans have sent to this asteroid have identified, and everybody's wondering what they are. At the moment, we cannot give you the answer to that, but maybe in a little while's time we will be able to. Thank you for listening.